Okay, so we all know that science education isn't just about memorizing the periodic table, right? It's really about developing the critical thinking and problem-solving skills our kids need to navigate the 21st century. But despite massive efforts to modernize how we teach, a stubborn gap is still hanging around. This is a global issue for sure, but today in this explainer, we're going to zero in on a really fascinating piece of basic research by Alvin A. Aliato. It's based in the San Mateo North District in the Philippines, and honestly, it captures this exact problem perfectly. And, even better, it points us directly toward an evidence-based solution.
To really grasp the scale of the problem here, just think about this number. In the second quarter of the 2025 to 2026 school year, only 6.3% of grade 5 learners in this district actually attained proficiency in science. Let me put that into perspective for you. Out of 555 enrolled 5th graders across the district, only 35 showed the required skills and competencies. That means a massive 93.7% of students were just at the developing or approaching mastery stage. This isn't just some slight dip in test scores, you know? It is a fundamental shortfall in foundational science learning, right at the critical grade where higher-order science concepts are supposed to take root.
So, seeing this huge gap between our 21st century educational goals and the stark reality of the data naturally leads us to ask, why? Why are our students struggling so much? Is it a lack of funding or resources? Is it a problem with the students themselves? Or does it have something to do with the people standing at the front of the classroom and exactly how they are teaching?
To solve this mystery, researcher and school principal Alvin A. Aliato didn't just guess. He actually launched a descriptive correlational study investigating the educators themselves. He wanted to see if maybe a lack of experience, poor education, or insufficient training was to blame. So he surveyed all 21 grade 5 science teachers in the district to build a super comprehensive profile of their qualifications and, of course, their daily instructional habits.
Now, here's where the data reveals an immediate surprise. You might be thinking, oh, they just need better teachers. But the problem absolutely isn't the teachers themselves. These are highly educated, experienced, and well-trained professionals. Nearly 43% of them have completed a master's degree. Over 80% have been in their current teaching position for 6 to 15 years, which means they are highly experienced and have well beyond the basic skills required. Plus, over 61% have attended rigorous division or regional level trainings. They are more than capable of handling the subject matter. So, if the teachers are highly qualified, what exactly is the disconnect?
Well, it turns out the crucial point is that the issue lies in the specific methods they're utilizing. The survey data revealed that these incredibly capable teachers are heavily relying on traditional, teacher-centered approaches. The methods they marked as always utilized were participatory learning, explicit instruction, and the classic lecture method. Essentially, the default mode of instruction is the teacher standing at the front explaining concepts while the students passively receive them. They're missing out on engaging in active, student-led discovery like inquiry or problem-based learning.
But how do we know for sure that relying on the lecture method is actually what's suppressing student mastery? To figure that out, the study used a multiple linear regression analysis to see what happens when teachers step away from the lecture podium and actually try different instructional approaches. By mapping the specific teaching methods against the students' actual class performance data, the researcher was able to isolate exactly which methods drive success and which ones hold students back.
And while the data speaks volumes here, both the inquiry-based approach and problem-based learning were found to be statistically significant positive predictors of learner mastery, meaning when teachers increased their use of inquiry and problem-solving, student performance went up. But here's the massive shocker. Project-based learning actually emerged as a significant negative predictor. Yeah, the more teachers used projects, the worse the students performed. We're going to get into exactly why that happened in a second, but first, let's look at our absolute strongest positive driver. Let's zoom in on that number one positive predictor: inquiry-based learning. Now, this isn't just an educational buzzword. It represents a fundamental shift in the classroom dynamic. According to the research cited in the study, this approach shifts the focus entirely away from simply memorizing facts from a textbook. Instead, it places the student right in the shoes of a scientist. It allows them to actively construct their own understanding through genuine exploration, rigorous experimentation, and deep questioning.
Okay, but what does this actually look like in a real classroom? Well, following the exact step-by-step indicators that successful teachers in this study use to implement inquiry-based learning, it starts with letting the students formulate their own scientific questions and hypotheses. Then, the teacher steps back a bit to facilitate experiments, allowing learners to test their own ideas.
Next, they encourage the learners to analyze and interpret that data themselves to draw conclusions. And finally, the teacher guides them in reflecting on those findings and connecting them right back to core scientific concepts and real-life problems. I mean, that is active high-retention learning in motion.
All right, but we absolutely have to talk about that twist in the data. Why did project-based learning actually harm student performance in this specific study? It sounds like an active, modern teaching method, right? Why was its beta coefficient a negative 0.2174? As this research highlights, leaning on a 2011 study by Boss, the problem isn't the concept of doing a project, it's the execution. Throwing students into unstructured, long-term projects without ensuring they have that foundational knowledge first just leads to absolute chaos. It results in what the study calls group work free writing and extreme frustration over how to synthesize information. A project without milestones or clear rubrics isn't a learning experience. Honestly, it's just a disorganized arts and crafts session masquerading as science.
And similarly, sticking to the highly utilized traditional lecture method fails for the exact opposite reason. As cited from Semigeni's 2023 research, if a teacher simply reads from notes without interactive elements or checking for deep understanding, students quickly disengage. The fault isn't with the educators, but rather that the method inherently forces students into passive listening and rote memorization. They struggle to retain massive amounts of information, and they totally fail to develop the critical cognitive problem-solving skills required for genuine science mastery.
So, recognizing that implementation is literally everything, because you can't just tell a teacher to do inquiry-based learning without support, Eliotto's research doesn't just point fingers, it proposes a clear, actionable solution for the district. It's not about blaming these highly qualified teachers, it's about shifting their instructional habits. The proposed solution? Crafting a district science education technical assistance plan.
This evidence-based plan equips teachers with exactly the tools they need. First up, it calls for targeted science teachers development programs specifically focused on selecting appropriate teaching approaches. Second, it demands regular, needs-based professional development so teachers aren't just reading about modern techniques, but actually practicing them. And crucially, it involves forming composite technical assistance teams to provide sustained classroom support and mentoring. This ensures that the transition from traditional lectures to powerful, well-structured inquiry-based methods is guided and permanent.
Because ultimately, as this data from San Mateo North District proves, the way we teach is just as important as what we teach. If we want students to master science, we have to actually let them do science. So we leave you with this provocative question to evaluate your own instructional strategies, or those used in your local schools. Will you rely on comfortable, traditional lectures, or will you take the steps needed to foster a true culture of scientific inquiry today? Thank you for joining this explainer. Keep questioning and keep learning.